talking about, and Aiden, go grab a calculator from back there. Talking about on Monday when we talked about looking at different jobs and which jobs offer different types of benefits and retirement incomes. And I got a lot of questions about, what do I do with retirement? How do I start? Where do we go? How much money do I put in there? How much money do I need in order to retire? And what was the big number that we talked about? Did we talk about this on Monday? How much money do we typically need to retire? Yeah, about $1 million. It's about $1 million that we need in order to retire. And I'm going to move this over here. Um, and honestly, you want to get more than $1 million to get it to be even more comfortable. Think about it. When you're retired and you're not working anymore, the um, the only income you have is that retirement money, and so you're going to need it. So I have some scenarios here that I want to go over with you guys. And it really just kind of puts into perspective the difference of time, which you cannot get back, and don't make the same mistake I did. And I'll talk about that mistake here in just a few minutes. Let's look at person A. Okay, person A has got into their groove later in life, has a stable job, but they don't start investing until they're age 40. Okay, and this is what they are going to do. At age 40, they're going to start putting in an investment account, $10,000 per year, into a retirement account with an 8% annual interest rate. 8% is a pretty a decent amount of interest rate. You could probably find those. That's like a long-term average there, but 8% interest rate, and they're going to do this for 20 years until they're 60. So every year for 20 years, starting at age 40, they are going to put in $10,000 into an investment account. They're going to retire at 65. So 5 years later, after they stop putting more money into this investment account, they're still going to work, but they're going to retire at age 65. Their lifetime investment into this account is $200,000. How did I get that? Well, $10,000 a year times 20 years is $200,000. So that means that they put in their own money, $200,000 over the course of their life, which really was just over the course of that ages 40 to 60. Okay. Now, because of interest, by the time they stop putting in money into the account at age 60, they're already up to $494,000. I'll answer that later. So obviously, look at this. Interest is keeping this money growing. You guys should remember from Algebra 2 that compound interest has money growing exponentially. So that's the reason why, even though they only put in $200,000 of their own money over the course of those 20 years, that money has grown to $494,000 by the time that they're 60. So 5 more years, they're going to retire. How much money do you think it's going to be at that point? Unmute yourself and tell me. What do you think? From $494,000 in just 5 more years, how much higher do you think it's going to be? But because he's not putting any more money into it. Talk to me, guys. I can't see a chat, so you're gonna have to unmute yourself. 500,000. Any other guesses?
700,000.
700,000. It's a good guess. It's gonna have $726,000 by the time he's 65. And that's just 5 more years after that growing compound interest. Is that pretty good? Huh? It's all right. I mean, it's not what we wanted to retire with. We wanted at least $1 million, but it's still a substantial amount of money to retire with. And you can still use that for other type of investments too if you want to. Let's look at person B. Oh, and then my return on investment. This person's return on investment is 3.6 times. That means that $726,000 is about 3.6 times as much as $200,000. They got 3.6 times as much as what they put into because of interest. And that's pretty good, making over 3 times as much. That's good. But let's look at person B. Person B is starting to invest a little bit earlier. They do it at age 30, but they're not making as much money as person B at that age. So they're only putting in $7,000 a year. And they're only going to do it for 15 years instead of 20. So they're putting in less per year, and they're doing it for 5 less years until they're age 45. They're also going to retire at 65. Now, their lifetime investment is a lot less. They're only putting in 105,000 of their own money because 7,000 times 15 is $105,000. And by the time that they stop putting in money at age 45, they've only barely doubled, not even doubled. They've only got up to $205,000. But how many more years is it before they retire at that point? They're 45 right now, 20 more years before they retire. So take a guess. I want to hear another guess from people at home. How much money do you think is going to be when they retire this time? They have way less money, $205,000. He's not putting in any more money. It's just going to grow until they're 65. Take a guess. I want to hear a guess from home. Maybe more or less than person A? You feel like it's a trick question? So what do you think the answer is? Probably more. $956,000. What's the difference? The rate was the same. They put in less money and they did it for less time. Why is it more money? The interest rate. The interest had more time to grow. And money grows exponentially when it's compounded at a certain time, at a certain rate. Look at this, 9.1 times what they put in. They only invested $105,000 of their own money. They got 9 times that much by the time they retired. And that's pretty comfortable to retire with. What's even better, though? Let's look at person C. And I'm going to show you guys this scenario because this scenario is not out of the realm of a possibility. I know that 20 years is just 2 years down the road for you guys. But this person started investing at age 20 and only did $5,000 a year, like $5,000 for the whole year. And only did it for 10 years until they're at age 30. 5,000 times 10, and they're also going to retire at 65. 5,000 times 10 is only $50,000 of their own money. That is half of what person B did, and that is a quarter of what person A did. And by the time they're 30 and they stopped investing their own money in there, they only have $78,000. What do you think they're going to have at retirement, though? How much more? More than $1 million? Do you guys think it's more than $1 million?
Yes.
Yeah. Look at this. Almost $1.2 million. 1.2. But here's the real kicker. It's not just the fact that they have $1.2 million. It's the fact that they got 23 times as much as they put in. That's the key. That is the big thing right there. And like I said, the mistake that I make, I'm showing you guys this stuff because I don't want you guys to make the same mistake that I did. And it doesn't have to be $5,000 a year when you're at age 20, but do something at age 20, right? I've been working full time since I was 18, and I didn't start investing until I was 24. And I really screwed myself. I put money into investment right now. I have a pretty solid retirement account, but man, it could be that much better if I had just started when I was 18, 19, 20 instead of waiting until I was 24. I really screwed myself. And it doesn't have to be, like I said, this, couple hundred, it could be $50 a month, $75 a month, $100 a month, something that your employer will match, because that's where that money is going to grow. And you can find good interest rates. You can put in a lot of money. You can do it for a long amount of time. You cannot get back time. You cannot get back time once it's passed. So obviously compound interest causes this to happen. And you see that you do it earlier, the earlier, the better. You can never get back that time. It's pretty cool, right? All right, here's the second half I want to show you guys. So I wanted to talk a little finance with you. If you ever want to get into like an accounting, not in just class, but accounting field, there are finance calculators out there that can help you calculate a lot of this different stuff. And these calculators actually do all these calculations for you. And they're called TVM calculators or TVM solvers. It stands for time value of money. And for you guys at home, since you don't have a TI-84, you can find them all over the internet. You can find them on the TI-84. But I'm going to give you guys this link to use because it's just like the one on the TI-84. as if you were guys here. So I'm going to put this in the chat once I can get this to pop up. Where's my chat now? There it is. All right, you guys click that. Oh, I accidentally just sent it to Destiny. You guys click that link and open up that this website right here. So, Aiden, if you go on your calculator, clear it out. Second plus sign 712. Second plus sign 712. And if you press the apps button, it's okay. And the very first one is finance, and then the very first one is TVM solver. Can you confirm with the people at home that what you see on your screen is exactly what they see on this computer page at home? Yeah. The only difference is that you have that end beginning at the bottom. Always just leave it at end. Okay. So before we use the finance calculator, you need to know what these variables stand for. And the first variable is the capital N. N stands for the total number of compounding periods in a year or the total number of payments in a year. Most of the time, N will be when we talk about compounding, there's really only two different ways that we're going to use it in this class, and these are the most common ways. Interest can compound monthly, which means it's happening 12 times a year, or interest can compound quarterly, which means it happens 4 times a year. Okay. If you're making payments on it, the total number of payments across all the years that you have a loan or all the years that you have an investment, this is what your N is. And I'm going to give you a few examples and show you how that works. I is easy. I is the interest rate, and it's written as a percent. You don't have to convert it to a decimal. That's the best part about finance calculators. PV stands for present value. Okay, it's what we have now. It's what if I have money that I want to put into an investment account. Let's say I want $5,000. That's my present value. If I don't have any money and I'm just going to start putting it in monthly, my present value is zero, and it's going to start to grow based on the payments that I make every month. Speaking of payments, PMT stands for payment, and that's a pretty easy one to remember. Okay. If PV stands for present value, what do you think FV stands for? Future value.
Future value.
Yep. Future value. Future value is pretty easy. That's what we want to get to. If I want to see how long it's going to take for me to get to $1 million and I can figure out what time I want to retire at, then I can use this feature to figure out what the future value is. The last two are PY and TY. They're always going to be the same. It's either going to be 12 or 4. You're either going to make 12 payments a year or 4 payments a year. I'm not going to give you any examples that are any other than that. You can't really find investments. Some of them you might do once a year, like the ones I did on those examples. But we'll just use either 12 times a year or 4 times a year, either monthly or quarterly. The last thing that you guys need to know about this finance calculator is the way that this negatives work. If you're going to pay something into an investment, if you have money to put into an investment or you're going to make a payment every month, those values have to be negative. It's because you're putting that money away or you're paying into that. If the money is coming to you, for example, like future value that you're going to get, those numbers will be positive in there. Interest rate will always be positive. You keep that the same and will always be positive. Okay. I have a couple examples and then I'll show you your assignment and you guys can scram out of here. Okay. Hopefully you have opened that calculator up already at home. That's the one that you guys are going to use. And I'll show you how to fill it out. And I'm going to give you this first example. When Crystal turned 22 years old, she inherited $20,000 from her late grandparents. She decided to put that money into a retirement account that has a 7.2% annual interest rate compounded monthly. I highlighted and bolded those just for a reason. She doesn't think she'll add any money to it, so she's just going to let it grow. How much will the account be worth when she turns 62 years old, the age she hopes to retire at? So let's fill this out together. I'm going to show you how this works. Now, on your screen, for the N value, from 22 years old to 62 years old, that's 40 years. Okay, so 40 years has passed, but the N stands for the total number of compounding periods. And there's 12 compounding periods per year because it says it's compounded monthly. So I actually have to multiply 40 times 12 to get 480. But I'm going to show you guys a trick when you're doing this. Go to your TVM solver, either in your calculator here or on this computer at home. And if you actually put in 40 and put the multiplication symbol, the one on the 8, the asterisk, times 12 and hit enter, it changes to 480. And Aiden, if you do that on the TI-84 calculator, it also does that too. Just put 40 times 12. So there's our end value. What's our I going to be? 7.2. That's easy. So we'll just put in 7.2 right here and look at our next value. PV. PV is what she has to invest now. How much money does she have to invest now?
$20,000.
$20,000. However, she's investing it. She doesn't have it anymore once she invests it. That number has to be negative in the calculator. So make sure you put a negative sign. And Aiden, on the TI-84, make sure you don't put a minus sign. You actually use the negative sign. Okay. What is our payment going to be? She's not adding anything to this. So what do we need to put in for payment? Just 0. She's not adding anything to it. On this one online, I think the one on here too in the TI-84 is default to 0, so we'll just leave it at 0. Future value is what we're figuring out. Okay, that's my question mark. Leave that one blank for now. Aiden, on your calculator, just leave it at 0 for now, and we'll come right back to it. All right. The last two, it's compounded monthly. So my PY and my CY are both going to be 12 because the interest is compounded monthly. If you change the PY to 12, watch what happens. As soon as I tab over to the next one, it also changes the CY to 12, and it does the same thing in the TI-84 calculator. Okay. Now, for you guys at home, we have everything put in here correctly. Now, in order to figure out how much money she's going to have in the future, I just got to click Solve for Future Value, and this number pops up. For Aiden, what you need to do is go up and highlight put the cursor where the FV is at, and press alpha, the green button, enter. Did it change that number to the same number that's up here?
Yeah.
Yep. $353,232.57. And that's how much money she will have, just letting that money grow. Literally, it's just growing into that investment account. It's not sitting in somebody's checking account. You don't want to let this money sit into a checking account. You inherit that type of money, you go somebody right away and you invest that money, because look how much it's worth in 40 years. Hey. Huh? Yeah, and I'm recording too. I'll come talk to you in a little bit. Okay. 40 years. Was it easy to use that calculator? Pretty easy. Let's do another example. For you guys at home, if you just click this little refresh right here, it clears everything out. Aiden, there's not a real easy way to do it on yours. Just start replacing the numbers with the other ones in the example. Try this one out, guys, and see if you can fill out some of these on your own without me, and I'll get to you. Pedro's 25. He wants to start investing. He finds a retirement account that has an annual interest rate of 8.1% compounded quarterly. What will his quarterly payment need to be if he wants to retire at age 60 with $1 million? So quarterly now is 4 times a year. So first of all, I need to figure out how many years is Pedro going to be investing his money in. He's 25 and he's going to retire at 60. How many years is that? 35. But instead of multiplying by 12 times a year this time, we're just going to multiply it by 4 times a year, because the interest is compounded quarterly. It's only compounded every 3 months. So 35 times 4 gives me 140. Go ahead and put the interest rate in, which is 8.1%. And don't put in the percentage sign, guys. Just literally put in the number. Now, PV, does he have a present value? Does he have any money right now? No money. Okay, he's gonna start putting in money. Whoops. I'll just leave that there. He's gonna start putting in money, but we don't know what he's putting in yet. So we're gonna leave PV at 0, and we're gonna leave payment at 0 right now because that's what the question's asking us. What is his payment gonna need to be every quarter? So what are we gonna put in for future value this time? $1 million. Okay, $1 million. And don't put in the commas on either one of these calculators. And what are my PY and CY going to be this time? Somebody at home answer this question for me. It's not 12. What are they both going to be? Anybody? Answer unmuting yourself, guys. Come on. Yes, Serial, it's 4. I don't have the chat pulled up when I'm recording this. All right. So it is 4. Go ahead and solve for the payment. It's the same exact way, Aiden. You highlight payment and put alpha enter. For you guys, you just click solve for payment right here. Now remember, my future value is not negative because that's what I'm going to take home. That's what I'm going to get out of this. But notice how when I solve for the payment ended up being negative. Remember, payment's always going to be negative because we're paying that out. But if you're doing a worksheet or you're answering this question, you don't need to write it as a negative number. And I would actually just write it as a positive number. So he would need to make quarterly payments of $1,301.85. Okay. That's quarterly. So that's every 3 months. So you divide that by 3, that's not too bad. A little over $400 a month to make that $1 million work. And that's not too bad. All right, I got 2 more examples for you. Let me throw a monkey wrench. Let me throw you guys a curveball on this question here. Marshall wants to invest $1,250. What? Oh, I know. I used students' names from different classes in an account that earns 2.34% interest compounded monthly again, because we're back to monthly. And he will make monthly payments into the account of $50. So how many years will it take for the account to reach $5,000? Okay, so how many years for it to get to $5,000? It's a low interest rate, so it's going to take some time. Which variable are we looking for this time? The n. Yeah, so n is what I don't know. So I'm going to clear this out and keep n blank because I don't know what n is going to be. You guys should be pretty good with the interest. So 2.34% here. And what is my PV going to be? Be careful when you put the PV in. Yep, negative 1250. It's got to be a negative because you're paying into that. Marshall's paying into that. And he is making a payment. This time payments are made $50 a month. And that's also got to be negative. So negative 50 is going to go into my payment. This time I want my future value to be 5,000. And that's going to be positive because once it's matured, once it's got to that future value, it will be money that he gets to keep and have. PY and CY are back to 12 because it does say compounded monthly. Okay, so make them both 12 and solve for n. $67.01. Does that mean it's going to take 67 years for this to happen? That doesn't seem right. Is it 67 years? It's 67 months. In this case, remember, don't forget that n is the number of periods that your money is being compounded. So there's 67 periods, which right now, since it's compounded monthly, that's 67 months. So in order to figure out how many years it's going to take, I just got to divide that by 12. Okay, I take 67.01, I divide by 12, and that's about 5.6 years. Okay, so this is one of those curveballs. You just got to be careful because remember, n is not the number of years. N is the number of years times how many times a year it's being compounded, or how many times a year you're making payments. If it was quarterly, then you would have divided that by 4 instead of 12. Okay, so that's the one I wanted to show you guys that it would take a little bit different. Let's I have one last example. I think you guys will like this example because it's taking. It'll be something that you're maybe interested in pretty soon. You can use these finance calculators to also figure out what your payment might be if you are renting a car or if you're buying a car. And I like to show you guys this too because here's the thing: when you go buy your first car from the dealership, the dealer is going to try to maximize their profit out of you. And the first question a dealer is going to ask you is they're going to ask, what can you get your monthly payment under? What do you want your monthly payment to be? Why should you never answer that question? I'm telling you right now, don't answer that question. Don't tell them, oh, I can afford, $500 a month. Oh, I can afford $300 a month. Because the dealer is going to manipulate everything to get that payment down to you, even if it means maximizing the interest rate, even if it means maximizing the amount of the car, even if it means maximizing the time that it takes for you to pay off the car. The longer you pay off a car, the more money and interest that you're going to have to pay on the car. That's the same way it works with any loan. Okay, so you got to be careful. Let's look at how you can use a finance calculator to figure out your payment. So you can actually go into the dealership knowing, do you have a good deal or not? Okay, learn this. Jalissa wants to buy a Tesla. You guys want a Tesla? I kind of want a Tesla now. I can't afford it, but I kind of want a Tesla.
That Tesla truck.
But yeah, I want the truck one. Yeah.
Because it looks like the Warhol product from Halo.
Oh, really? Sticker price, base model, $39,990. She's going to need a loan from the bank. The bank approves her for a 6-year loan with no down payment and an interest rate of 3.79%. What will Jalissa's monthly payment for the car be? All right, so we're going to use a finance calculator, but we're going to change this up a little bit. What's my N going to be this time? She's making monthly payments for 6 years. So that's going to be 72. She's making 72 total payments, 6 years for 12 payments a year. Let's fill that out. Ready to figure this one out? Interest rate is 3.79%. All right, Christiana. We're going to go backwards this time. What's my present value? What do you think? This time we're getting a loan from the bank. Is it going to be positive or going to be negative?
Can you say it again?
I asked what, I already put it up, the answer up, but why? So tell me this. Why do you think the present value is positive now?
Because you got the money from the bank.
Because you got the money from the bank. It's a loan. You owe that money. You didn't pay that money yet. You owe it. So now we're going backwards. The present value is the amount of the loan, and since you owe it, it's a positive number. So let's change this. $39,990. We're trying to figure out what the payment is. So leave that blank for now. Leave it at 0. And then when you're paying off a loan, you're paying off a car, what do you ultimately want the future value of the loan to be? 0. Yeah, you're paying the loan off. So make your future value 0. This would work with any loan if you ever wanted to use a finance calculator and figure out how much your payment would be on a loan. Make the future value at 0. PY and CY are both 12 because you're making monthly payments. Figure out what that payment for that Tesla is. Ready to see how expensive it is? $621.83 a month. I guess if you're making money, that's not bad. 6-year car loans are a long time too. You know, they used to be 5 was the max. Now they do 6 and 7, I think. Careful getting into those 7-year car loans, guys. That's a lot. Okay. What do you guys think? It's pretty easy to use a finance calculator, right? You can actually buy finance calculators with all this stuff like right on the front. Accounting people have this stuff, but it's super. I think it's something that you guys really, really need to know about, especially if you're out to go buy a car pretty soon. Okay. Take a look at your homework. So your homework should be pretty easy. It's 1 page, front and back. On the front page, you have 6 problems, just like what we did, and you're solving for one of the variables. If you look at the answer blanks right here, it kind of figures out which of the variables that you're looking for. Okay. Use the little tables there to fill out on your paper once you print it out or in your journal, and then put it into the calculator. Put it into the calculator on the other page. On the back page, I have a couple of scenarios where you're going to look at 2 people buying the same car but have different interest rates, and see how much it different affects those people. And then lastly, you're going to actually find a car online, find out what the interest rate would be. But I kind of threw a twist in there. Your interest rate is going to be based on your grade. So look at your grade from the last 9 weeks, and the lower your grade was last 9 weeks, the higher the interest rate is going to be. And then the better your grade was, the lower interest rate is going to be. So those of you that have good grades, I'm going to basically say you have good credit, so you're going to have lower interest rates. But use those, find a car, figure out how much it's going to be, and then figure out what your payment would be on it using this calculator. Okay. Any questions, guys?